Okay, folks, so it's bang on 3 o'clock here in Sydney, and I'd like to welcome Siraj to the TFF APAC. Siraj runs a visual analytics consulting company based in India, and he's been working with Tableau for over 3 years now, usually working with large enterprise customers to helping them use visualization and analytics to solve critical business problems. Siraj has actually thrown out a great challenge, which I find really interesting. Is it possible to explain table calcs and level of details to your grandma? This is an amazing 45-minute talk focused on the foundational understanding of table calcs. So welcome, Siraj.
Thank you, Fee. Are you able to hear me?
Oh, yes, we excellent. Can see you and we can see the screen.
Oh, excellent. So here is the agenda. So typically I've presented this session to the user group about 3 to 4 hours. So I've tried to take the biggest insights I've presented and sequence them. Let's see how much we can cover in 45 minutes. So I'll get started off with the first big insight, which really started this journey of what I call the explaining this to grandma type of journey about table calculations. And then I summarize the problems that table calculations address in terms of 3 paradoxical problems that they address. So, and then we will move on to talking about how do we define table calculations and can we give a better name that makes it clear what we are trying to do here. And then we'll come back and map these 3 paradoxical problems to the 11 quick table calculations that we see whenever we look at this. And then I'll also point you to next steps in terms of how do we take it forward in terms of learning. So here is the first big insight. So before we get started, let's just take a beginner's approach and ask the standard questions that everyone would ask. What's a table calculation? Just let me check whether there's a problem with the... Yeah. What's a table calculation? And then when do I use them? So these are the standard questions everyone will ask. And if you look at the top resources for understanding table calculations, the first one is obviously the manual by Tableau itself. There is 2 versions now, 9.3. A lot of us still use 9.3 and then version 10 as well. Then there's a white paper as well as a top 10 table calculation thing. Tableau's Zen Master Jonathan also maintains a longer list graded by whether it's beginner, intermediate, and stuff. That's what we have. So let's look at what the manual says. The manual says table calculations are computations that are applied to the values in the table. This is like saying table calculations are calculations applied to the values in the table. It's a circular definition. It doesn't really help us to understand what this is. The primary challenge I see with almost all the manuals surrounding table calculation is they keep talking about this proverbial table without explaining what table are we talking about. For most people, table means something in the database really, right? Is that what they are referring to? And the second part of the definition says these computations are unique in that they use data from multiple rows in the database to calculate a value. First, I mean, does it give you any more explanation of what's a table calculation that it uses multiple rows? The second, this is outright wrong. When you drag and drop any pill, any number pill, measure into Tableau, by default, you are bringing in an aggregation. That means more than 1 row is coming. So table calculations are about what you do after this first step of aggregations. That's what they are. But this documentation doesn't make it clear. So there's a lot more things that I put, but we'll skip all of this. What I wanted to establish is all of these things do not really help us to answer these questions, right? What's the table calculation and when do I use them? When I was new to Tableau, this is about 3 years back, this was what I was, we in fact engaged the Tableau team to do a POC comparing ClickView and Tableau, and some of the very complex calculations, they were able to execute using table calculation. So I was curious to find out how did you do that? But neither was he able to explain, nor the documentation was helping us to understand what's really going on. So what's a table calculation? Based on whatever we have seen, it's a transformation you apply to a single measure. If I just go back to the version 10 manual, to me this actually is a better version. I mean the best that I've seen in the definition so far. First time it talks about a view. It says in a view, that means we are talking about a report within Tableau, not database table. And it's saying you are applying a transformation. Transformation is a technical word, jargon. So, and then they give examples. One type of transformation is ranking, other is running total, other is percentage of total. At least this helps us to form a slightly better picture compared to anything else we have seen. So if I go back, so the one thing that we understand is it's a transformation you apply to a single measure. And then addressing and partitioning are used to define a table calculation. In this 45 minutes, I'm not going to touch this, but in the longer session, I do talk about this because those are the real two difficult concepts to really help people to master table calculations. So, and then when do I use them? There's no clear answer. What we keep seeing is a number of examples. Running total is almost like a brand ambassador for table calculations. You see it in every documentation. And then we see percentage of total, we see rank and all of this. So let me kind of switch to my story with table calculation. I've alluded to this. I have given a more detailed story in a forum post that you can check out later on. So initially, I mean, for me, any concept I'm introduced to, I want to understand that at a very deep level. What's really happening? What's happening at the database level? What is this tool trying to do? So that when I apply it to an advanced calculation, I have 100% confidence. I know what's really going on. But table calculation was like this black box. Not only what it is doing, how it is doing, and how do I control was not really clear. Until one point, actually, I mean, it was an epiphany for me looking at an Excel menu. So this was a table like this, you know, so just run of the mill, some pivot table. I right clicked on this and I suddenly saw this menu, show value as. And then it has all of these things, percentage of total, different percentage of total, difference from running total, rank. And I said, I remember seeing this somewhere. I was near Zurich that time. I mean, teaching a class of Unilever about Power Pivot. And then I opened this Tableau menu quickly and went to this quick table calculation. I see similar stuff, running total, percentage of total, difference. Let's put them side by side and zoom up close. Look at the striking similarity. Look at all this percentage of total is here, you know, this. So I realized it's all about displaying what's there on the report in a different way. That's all. Instead of just displaying the raw value as it is, you are just displaying it in a relative way compared to another record or compared to the grand total. That's what really it is. And then what a clear name Excel has come up with, right? Show value as, right? I can show this, the sum of salary. Instead of that, I can show it as a percentage of the whole year. I mean, all the years, or I can show as the difference from the previous one, or a running total, you know. So so I actually just this week cooked up this menu. How nice it would be, you know, if Tableau had a menu like this. I right click on the value itself. Right now in Tableau, now you have to go to the pill which is located somewhere else, which is a mental disconnect. Instead of that, you are seeing a value, you right click and you see, instead of showing this 14,000 as a number, can I see it as a running total, as a difference? I think this would have eliminated a lot of these very difficult explanations and pages and pages of explanations about what table calculation is and that. So that's really the big insight for me. Table calculation is a way about changing the display on the report. That means you first need to have a report first. That means we are not doing this at the database level or any data source level, right? So first we bring in an aggregation, which is summarizing using one of these, you know, aggregation functions, sum, average, min, max, any of that. And then you change the display. It's almost mentally, you can imagine you have a report, you right click on that report, and then you choose a way to show this relatively. So now let's look at, you know, the two questions we started off with. What's a table calculation? I think now things would have been much clearer to you what a table calculation is. But when do I use them? Right, we have a definition, great. But do I really need to memorize these long lists? I mean, if I'm faced with a practical problem in of other calculations that are available, what do I use? The answer is you don't need to memorize these lists. So in order to really understand when do I use table calculations, you have to understand the three paradoxical problems in the reporting world. This is my own conceptualization to just kind of group these things and just make it simple to understand. So let's get started into what these three paradoxes are. What's a paradox? Let's define this. Not everybody is clear on this term. So this is what dictionary says. What I really like is this third one definition: a person or thing that combines contradictory features or qualities. So when we talk of a paradox, we are talking of a contradiction. There's some contradiction in there. So what is the contradiction here when it comes to some 3 problems in reporting? What problems am I referring to really? So let me tell you what the contradiction is, then I'll introduce these 3 problems. These 3 problems, if I take any one of you in this audience and give it to you to do, you would find it very easy and intuitive. And if I ask a database to do, they will find it hard and unnatural. I mean, it's quite surprising in this world of big data where we have millions and billions of records being summed up in fractions of seconds, and still something that we easily do, databases struggle with. What is that? That's the paradox really. So to illustrate this, let's start with this simple report. Nothing fancy here, just 3 years, simple numbers that you can add up, right? Everything is right, nicely rounding up. So what I want you to do is to add another column and display the difference in sales from previous year. So the people in the audience, I mean, just take a pass and do it now. It's a very quick calculation. Okay, so here is the answer, right? So we take the 2012 value, just do this minus this, we got this. Was it hard for you? I mean, you would say it was super easy. In fact, in my sessions, I give a little more build up. I ask them to take a paper and pencil and then do the calculation. And then most people don't even use that. And then, on the fly, they do it. If it is so easy for us, why is it hard for databases, right? It's perplexing really. So to understand why it is hard for databases, let's reflect a little more consciously. What operations are we doing here? So let's take this 2012. We took this value, 15,000, current value. I went 1 record before. I took the previous value, and then I'm doing a subtraction. Really, I'm doing 2 things. I'm finding the previous value. I'm doing subtraction. Subtraction and any mathematical operation databases have been doing for quite a long time. So that there should not be any difficulty. Then obviously the difficulty is in accessing a previous record. For us, the concept of a previous record, when I look at something, is so intuitive. I mean, we don't think what previous is, right? But for databases, they are there. To be really, fair, let's look at what databases are good at, right? So first, they are extremely good at aggregation. Give them a billion of records and ask them, give me one value, some min, max, they're gonna, come back to you very quickly. Filtering, take massive data sets, filter them, and just focus on a few things. Really great. I'm talking only from a reporting perspective here. And also sorting. These are the 3 basic, almost atomic operations in reporting databases are extremely good at. But what happens is, databases, there's no provision to go back to the previous record or the next record really. To be fair to the databases, they were not originally built for that in any perspective. But we need it all the time. See, one of the nice things about Excel is it makes this operation so easy. Just going back to the previous record, put a up arrow or just move the mouse over, and then it gives you access to the previous next. That's why, I mean, I've lived in Excel for a long time before actually moving on to BI tools. So it's such a darling because it gives you all of these possibilities without writing any complex equation really, right? So in Excel, you build a pivot table and then you can do this minus that. It's not a dynamic calculation, but still, for most people, it's accessible. So let's give this problem a name, a good name that helps us to easily remember this. Take a moment again and think of what is a good name that you would give. So let's summarize what we are doing here so that, before we give the name, it's very clear. We take the current value of the sales measure, and then we compare it to the previous value, right? In other words, what we are doing is me versus my peer, right? So in this case, along the year, we are taking this, any peer, so I can compare to the previous value, next value. So it's about a comparison within a peer group, really, right? So we can give it a name, peer comparison, right? So this is a fair name, so we are comparing it to a peer. So, but what I like to do is to give names which evokes emotions or helps us to visualize something. We are in the world of visualization anyway. Here is a better name, peer pressure. Better just because it invokes emotions in us. All of us have been through this, and till date, I think all of us are going through this, right? Peer pressure, whether it is at work, at home, when it comes to our kids. I mean, it's always there, right? So let's summarize the peer pressure problem. So the peer comparison is a very instinctive drive for us. We do it all the time. Look at the questions that we ask. I mean, our children bring their cards. We ask them for their rank, relative performance vis-a-vis other students. And then I have not, met an executive who is not focused on the top performers, bottom performers, what are my top products and all that. And then year over year growth percentage, compared to last year, compared to last quarter. So all of these are about peer comparisons in different domains really, right? So peer comparison is something that is so intuitive. Hence, we ask this question all the time, but for databases, it's a bit hard. So that's why this is the paradox one, right? Something that is so easy and intuitive for us, but for databases, it is hard. So that's the first paradoxical problem. So are there any questions here? Maybe I should take some questions. Normally, I get a lot of feedback from people, so it's hard for me to present without even knowing whether people have any questions. So let me see. Are there any questions?
So there haven't been any questions that have come through so far, but I just really love your way of simplifying things to actually get pen and paper out, or even if we open up good old Excel and do the calculations in there. I think it's a great thing for people to understand, let's double check what's actually going on while we get under the hood. So I think that's a fantastic first step. Thank you.
Thank you. Yes. Okay. Yeah, I rely on you in case there's a problem in presentation, something gets cut off, so bring to my attention, please. So let's move on to the second problem. I'm talking at a faster pace. I hope, most of you are able to understand given it's a 45-minute session. So for the problem 2 also, let's use the same report. So this time I want to change the calculation to look at cumulative sales figure, right? So last time we looked at difference, this time let's look at cumulative sales figure. So again, can you pass and do it now? Maybe quickly mentally. So here is the report with the cumulative sales. Again, I don't even need to ask, you would say it is easy. So it's still hard for the databases. You might be chuckling, come on, it's the same reason, right? We are accessing, the previous record. So what's interesting is, previously database was suffering from us, answering our one previous record question. Now we are asking, give me the whole bunch of previous records really. That's what we are asking the databases, right? As we move to each new cell, we are taking on more and more values, right? So for each cell, we are collecting a whole set of values, almost like a window, right? We take a bucket and then from current cell, the bucket collects, all the way up to the first cell, and then we are moving on. This is how we are doing here, right? In other words, I mean, all of us know what accumulation is. It's a very common term that we all know. So we are doing a plain vanilla accumulation really, right? So let's give this a good name. What's a good name? So, I mean, accumulation really pops out, right? So in the convention of really, I mean, kind of, making it a little bit, non-serious. So let me take you on a quick detour. So to find a slightly better name. So do you know Steve Jobs? Is there anyone here who doesn't know? Okay. So have you listened to his Stanford speech about connecting the dots? If you have not, my sincere advice is listen to it. No matter what type of work you do, I mean, stay hungry, stay foolish is a great caption. And then his story is very inspiring, So he talks about how, seemingly unconnected events in the past, he dropped out of Stanford, joined in some art class, eventually led to the creation of beautiful fonts on Mac, which we are all enjoying today, really, right? So it's like going back to the previous events and kind of connecting them together. So do you know what's the relationship between Steve Jobs and Tableau? So Steve Jobs, there was a time he was fired from his own company. It's an irony. So, and then he started his next venture called Pixar. His intent was to do 3D animation movies. The Tableau is one of Tableau's co-founder as well as the mentor of Chris Talte. So Professor Hanrahan, he was the man who worked with Steve Jobs to create this first 3D movie, really. Then he kind of came back and then Tableau started. So that's connecting the dots from Steve Jobs to Tableau. So in a way, can I take the liberty to say this is a connecting the dots problem, right? We are taking for each value, previous values, and then connecting them and to arrive at a single value really, right? So let's summarize this problem. So this is the second instance. Looking at figures cumulatively is another instinctive thing we all do, right? Look at the kind of questions that is asked in business all the time. Year to date sales, month to date sales, a running total of different things, cumulative expenses, cumulative budget, and all of this, right? So variations of the same thing. And even a more complex calculation like moving average, which is used in the stock market and very few specific domains, it's also variation of the same problem. We take a window of values, instead of adding them up, we are just averaging them. That's it. The window keeps, kind of the size of the window remains the same, and it keeps moving instead of, expanding like in running total, right? So let's summarize the two problems that we have seen so far: peer pressure problem or peer comparison, to be more formal, and connecting the dots problem or accumulation, to be more formal. In the first problem, we focused on a single previous value. In this second problem, we focused on a window of previous values. You might be wondering, come on, what are you next going? Previous values, can we change the topic? Yes, for the problem 3, let's take it to another level, right? So the watchword here is level. So I'll explain what that means. So let's take our discussion to another level and look at sales by VIP customers. Look at who landed in our store, right? What a great store, right? So all the presidents of the US, lined up to buy stuff from us. So this time what I want to do is, I just want you to display the percentage of sales that came from each of these US presidents for us. So can you take a moment to do this? This will probably take you a few more minutes or few more seconds. So here is the answer, right? Round numbers, 20, 30, 50. So was it easy or hard? Compared to the previous ones, maybe a little more involved, but it is still easy. So it's hard for the databases to do it. And this time you are not accessing the previous record, right? So what's going on, really? So to really understand what's going on and what's difficult here, let's again reflect on what operations are we doing here, right? Consciously, step 1, step 2, that fashion, really, right? So what we are doing is, for each cell, we take this cell, right? First, we find out the grand total. And then we take this number and divide it by the grand total, really, right? Super simple. What's complex about this? So then now let's come to Tableau. How do we do this in Tableau? So first, find the grand total. This is the report. Just drag and drop, sales, and it's going to put sum of sales. You got this. And how do I get my usual report? Customer name. I dragged and dropped customer. So now the difficulty is, so I'm going to take, customer sales and divide it by the grand total. So the numerator is customer sales and denominator is grand total. And if you look at this one, or I have it here itself, both of them are sum of sales, right? So here, if I don't have a customer, I get this 50,000 value. If I have customer, I get 10,000. So if my report looks like this, I am going to get 10,000 by 10,000 for the first value. If my report looks like this, I'm going to get 50,000 by 50,000. It's always going to be 1 here. So this is the difficulty here. For those of you who understand the concept of level of details, here we are talking about 2 levels of detail, really, right? Here, grand total is operating at another level of detail. Here, this is customer is the level of detail, right? So that's why in a single calculation, one part of it, we want to channelize, the current level of detail. The other part of it, we want to ignore that and we want to go to 1 level up, really, right? So there are 2, I've already summarized this. So it's hard for the databases to do this because it involves 2 different levels of detail in a single calculated field. If I'm talking to a real group, I would actually segment them into 2 types of users. Ask the technical folks, why is it difficult? The answer I get is, typically in a single query, you can't do this. So for grand total, you send a separate query. And then for each customer, you send a separate query, right? And then combine them in the form of a sub-query and main query. That's how you have to do it in databases. There are some databases which support this, but not everyone. In case you don't have a database background, if you're working on Excel or just your exposure is Tableau itself, it's like you have 2 different reports and you have to come and combine. In Excel, you can put them side by side and you can do this divided by that very nicely. But we are in the world of Tableau, you can't do that, right? So that's why it's really difficult here, right? So whenever a calculation involves more than 1 level of detail, it's difficult for the databases. Essentially, you will have to do 2 different queries or two different steps and then combine them in a certain way, right? So that's why this is a paradox. So the third problem, let's give it a good name. What's a good name? So let me call this son versus father. Really, I wanted to come up with a good name because we are at different levels. There's son, there's father here. It's like, I remember reading a very nice book called What Got You Here Won't Get You There by Marshall Goldsmith. It's another great book, one of my favorite books. This talks about 20 traits of very successful people that actually stops them from growing. So one of the things he talks about, when son and father are playing basketball, and then after a point, the competitive instinct in the father kicks in, and then he wants to beat his own son. It's like two different levels of people playing, really, right? So that's what the image I have in my mind of this. So let's summarize this problem also. A calculation, a single calculation involves taking one value from one level, like customer sales, and then taking another value from a parent level, which is like a grand total level, and then you are dividing here in this case because we are looking at a percentage of parent. So this percentage of parent calculation is one member of a big and special family. And this family is so important. They are almost like VIPs. That's why actually I gave the report a lot of VIP names, really, because these are VIP problem statements. So I mean, since we are not going to be talking beyond this session, let me give you the clue itself. This VIP family is the reason the whole LODs came into picture. So this is an instance, one instance of the LOD problem. LOD, level of detail calculation, you can already relate. When I introduced the problem, I told you level. And then here we keep talking about level, right? And then you know where I'm going. So the whole family of LOD of calculations include, exclude, fixed, all of them were created to more elegantly solve this problem that Tableau had its first attempt through table calculation. You know, there are some merits too. So this is a single problem in these three families that you can do either using LOD or using table calculation. The first two families, you can't do them using LODs. This is a common question I see in the forum. When do I use LOD? When do I use table calculations, right? I'll summarize them again, but this is the thing. This is a problem that deals with LODs, but it is packaged as a table calculation really, right? So you can do it there also. When you do it through table calculation, you can do it using your mouse, right click, choose some options, you know, as long as you understand what addressing and partitioning means. And when you go to LOD, you have to write the equation, but it's much more intuitive really. So let's summarize the third problem also. So the third problem is about two different levels, son versus father problem, right? So two problems to deal with accessing previous records. One problem deals with two different levels of details, really three different, you know, problems. So here is the grandma script. I actually wanted to create some sort of a nice animation and a storyline and you know, but I didn't have time really. So here is what I have in mind at a very high level, right? So if you talk to your grandma really, right? So it's like this. So let's assume I have this conversation with my grandma. I ask her, Grandma, I mean, I find it very hard to really control my expenses and manage my finances. And how did you do this? So grandma says, you know, grandson, so so we have this concept called envelope budgeting we used. So whenever the money comes in from grandpa monthly salary, so we divide them into three really buckets. So one is our routine spending monthly account, and the second is savings account, and third is charity account, and we put, you know, some percentage here and there. So that's our first problem, percentage of, you know, total problem. And then, so every month I keep track of all the expenses under different categories, and then look at what are my top expenses. That's our peer pressure problem, comparing top, ranking, and all of this. And then as we move through the months, I also look at cumulatively what's going on, you know, because there are some accounts where I don't spend month on month, like buying gifts, buying clothing, and all of that. I look at them cumulatively, right? That's connecting the dots problem. This is the grandma script. I'll probably over time add some more drama and make it, you know, much more really presentable. So, but in a single, you know, conversation, you have all the three table calculation families summarized really, right? So that's the beauty of these table calculations. These are almost calculations we do on the back of the envelope. It's almost, I want to say, like table salt is, what is table salt? Table salt is like a common salt that you find on every breakfast table. It's like table calculation is the calculation you do at breakfast table or dinner table. It's so common, you know. That's one fancy way to really think about table calculation, really, right? So let's get a little bit more serious. Let's come back. Now we are professionals. Let's define what table calculations are. So now that we have gotten these insights, right? The first big insight, table calculation is about display. And then the three groups of problems that it addresses. Let's use this to give a better name. So given, I mean, in a long session, I use it as a break, so that people a little bit, get disconnected from table calculation and do some sort of these nice games. But anyway, here I'll skip. So here is the related thing. So you have to find three commonalities between these three problems, right? So what are they? Take a moment to reflect. They all use sales. That's not what I'm looking for, right? So another three. So let me say. So the one, we are working on the values from the report. If you look at this, so we started off with this report. I haven't even shown you what the data behind the scenes is, right? Whether it's 3 records, 20 records, 100 records, you don't know. You never have to, ask me, can I go back to the data source? So that's the first thing. We are working on the values that we see in the report, and we do not have to go back to the source. So can we give them a name based on this commonality? Since I've already shared the first insight in my session, I actually bring it to the end. But here it is a report level calculation. That's what I wanted to be clear. This calculation is happening at the report level, and it's done by Tableau. So table calculations, so the definition part one, table calculations are performed on the values that you see in the report. And then we are working on a single measure, right? We are not taking sales and comparing it to profit or something, right? We are still comparing only within sales. We are not going to another measure, right? And so this is the second part of the definition. It's on a single measure. And then third commonality is, if you are looking at these first two, we are moving up and down, previous, next, right? Here we are going one level up, right? And I talking of the bigger family of LODs, we could go down also, but in table calculation, we talk of going one level up, right? So we are moving up and down and never worry about really other columns. So that means we are using the position in some way, right? We are moving through the values in the rows, right? That's what we are doing. So that's the third part of the definition. We use the position in some way. So three-part definition. The simplest thing is it's on a single measure. That I think already Tableau makes it clear, right? So these are calculations performed on the report. If you are a beginner, even if you are writing an advanced table calculation, I almost want you to visualize you have a report. Drag and drop, create the report, then think of what do I want to do. That's much better way to get started and write a very solid table calculation equation. And then when do I use table calculation? Whenever you are using position in some way, there's nothing that you can do in the world of Tableau without using table calculation. For the level of detail, you have a solution in LOD. But the moment you use position, which is the first two families really, right? So that's what it is. So if I want to give a really big name, I would call it position-based calculations at the report level. I'm giving this mouthful name really because I just want you to understand that's what it is. It's at the report level. This is position-based calculation. These are the two keywords. But if we take inspiration from Excel, we can call it show value as calculations or relative value calculation or display level calculation. Find whatever term that really helps you. I want you to visualize the Excel menu. I want you to remember positions. I want you to remember that it's happening at the report level. As long as you remember these three fundamental principles, I mean, you would be safe with doing any type of table calculation. Okay, enough theory. Let me take a look at the time. It's about 10. That means I have about 10 minutes to go. Yeah. So, Fee, is it correct? I have 10 minutes to go.
Yeah, so we don't have our next session until 4 o'clock, so you've got a fair bit of time. We'll see.
Okay. Yeah, anyway, so I kept the session so that, so depending on whenever you cut me off, I'm happy. I'm so passionate about this topic, right? So great.
It's great. I love it. I love the little breakouts,
Yeah, it's a very serious topic. Even I get very serious. I thought it's good to have some breaks. So let me show you a screenshot, really, finally, of table calculation, right? So let's map these. So I remember the second question we had is when do I use this? And I told you don't have to memorize these long lists. You can as long as you understand 3 paradoxical problem families, you would be able to, understand when to use them. Now, let me illustrate what I mean by taking these families, 3 families, and mapping them to the calculations that you're familiar with, which is in this dialogue really, right? So here is the first one, right? Let me start off. I'm switching the order a little bit because, running first, one reason to, as a tribute to Tableau, running total is the brand ambassador of table calculation. So that's in one way. Other thing is adding things up is very easy for us, really, right? So running total, right? So if you take this report, we are just doing this. That's the first calculation. Moving average, I've already told you, moving average is if you take a 2-year moving average, we take these 2 and divide it by 2 and put it here, 12,500. Then we take these 2, 40,000 divided by 2, we put it here. Again, simple stuff, right? So the window keeps moving, the size is the same. And YTD total is nothing but a variation of running total, but you have basically something along the calendar dimension, like a quarter, month, and year. Because in typical sales situation, we want to look at, for example, what's the running sales, like we are today now in October, right? So what's the year-to-date total so far in the sales now compared to last year? How did it grow? Those are the questions we ask. It's nothing but really a variation. So in other words, cumulation, you either do a fixed window and you can do a sum also. There are cases where it is needed. Typical is moving average. You can do moving min max. These are some of the things that are discussed in advanced table calculation classes in the conference. Running total, very common, very common use, almost all the time in any work, whether it's budget, whether it's expenses, whether it's sales, we look at cumulative numbers, right? So it's all about adding things up really. So now I go back to the first problem, peer pressure family, because this family is slightly big, right? Because it also occupies a lot of attention, like it occupies a lot of attention of us, right? Peer pressure comparing to our peers, right? So the first problem is this one. So we have seen difference. That is what I marked here. The second one is percentage difference, nothing but this 5,000 divided by 10,000, so that we know this is a 50% growth from previous year. Let me pass on compound growth rate. Let me go over to YTD growth rate. So previously YTD total we have seen, right? So if I take this year's YTD total, like this October, from January to October, compare it to last year, same period, and find the percentage of difference, that is YTD growth, really. And then year-over-year growth, let me take the sales 2012 compared to this, what is the year-over-year growth, right? Just 1 year. Nothing but the same as percentage of difference in this calculation. But in a monthly level, it can actually, so it's a variation of the same percentage of difference along the time dimension. Compound growth rate is used in the investment world, and then we all have learned this by our investment advisors, the power of compounding, start saving early and all of this. This is about, if I do, for example, so what's the growth from 2011 to 13? That's 3 years. Let's say I invest 10,000 in my stocks and I got 25,000 in 2 years. So what's the percentage of return? The simple thing we will do is I got 15,000, right? That's on 10,000 as a starting point. That's 150% in 2 years. So divided by 2, you get 75%. In a compound growth rate, you use the power of exponential. So for example, you take the starting value, you take the ending value, and then you do n divided by start, and then you apply an exponential based on the years, and then you get this 58%. So what is the meaning of this 58% is, so I take this and then 2 years I multiply 2 times, you will get the starting value. That's what it is. So it is useful in a number of areas to if you want to normalize things, to understand how steadily they are growing. People think it's very specialized. It is not. Even when you're looking at traditional company sales over a longer period of time, rather than doing a simple arithmetic, this would have given you how it is growing much more consistently. This is a better number to use, right? So that's, those are the 5 things when it comes to peer comparison. These 2 are nothing but variations of difference and percentage difference, right? So here the thing is, we are all comparing a peer to another peer, just one-on-one comparison. In these 2, rank and percentile, what we are doing is, we are comparing it to the whole population of peers, but we are just doing a number, assigning. That's it. We are not doing subtraction, adding up, or anything, right? So we take the whole report, we give them a number, like 1 to whatever number, based on whatever sorting order we use. And then percentile is nothing but basically a percentage of how many people are below me in the rank. It is used in the academic circles. We all know SAT percentile, GMAT percentile and stuff. But it's also again useful in a lot of business scenarios as well. So that's the peer pressure family. And then the third one is, percentage of total, a lonely figure sitting here, it doesn't belong here. It is already, showing here. So here we are comparing it to a parent. That's the essence. Actually, this problem is also much more actually complex. So if I look at a report like this, right, you get actually a lot more options. Look at what Excel is giving. Tableau is giving us 1% of total. Excel is giving 7 options, right? And that also, it gives you a free-flowing option, percentage of anything to anything. So here I'm not going to go through the detail, but you can look at this. For example, percentage of grand total is this number, column total, row total, parent row, parent column, and then anything. So really, right? So that's basically, now I have mapped all the 3 families back to these equations, right? So when you are encountering a real problem in your domain, right? The question you ask is, do I need to use a previous record or a next record in any way? If yes, am I referring to one or multiple? If it is one, it's a peer comparison thing. If it is multiple, it's a variation of cumulation problem, connecting the dots, running total problem. Am I talking about 2 different levels here? Am I comparing one at a child level and taking it and comparing it another at a parent level? Then this is the parent versus child, problem. And this can be solved both with table calculations and with LODs. In most cases, LOD solutions would at least seem more understandable, because addressing and partitioning, the concept of it is not very clear to most people, right? Which I do cover. Maybe, we'll figure out some ways to cover this. So just to summarize, this is what I intended to cover in 45 minutes. So table calculations are calculations done on the report after the results are returned from the database by Tableau, within Tableau, really, right? That use the position in some way. That's really the definition, right? So here is a quiz for you to test whether you have really understood. Did you notice I used 3 colors? Fee, maybe I should put you on the spotlight.
Yes.
sorry, yeah. You are really ready for hosting me. So do you remember the colors that Tableau uses for continuous and discrete?
So off the top of my head, I think that the continuous ones are the blue pills and the discrete ones are the green pills.
Okay.
Did I get it around the wrong way?
Yeah, exactly. You are. I put you on the spot. Sorry. I've already given you clues. Continuous is in green, discrete is in blue. Right? So really, I mean, this is just one other conceptualization I came up with. If you understand it, you can take it. Otherwise, you can leave it. So basically, if you look at the running total, right? So what's the concept of continuous and discrete in Tableau? Continuous is you are connecting the dots, right? So you put something continuous on the chart, it is going to connect the lines. It's going to draw an axis. That is what we are talking about, right? So if you look at our comparison family, this family, connecting the dots family, it's about continuous, taking more than one value and connecting it. That's why in a way I put them on green, these 3 problems. And then discrete is taking one value at a time, right? Like the typical discrete thing is any dimension, when you put them, they come as individual values. Here also we are looking at, each number, it has its own place, me minus my previous one, or me versus the other rank, right? And then I have this one, red. Why red? Again, P.
Oh yeah, so that's still me. So the red ones are when I cry. when things go terribly wrong.
Exactly. So the red is because red actually doesn't fit here, right? So basically, I was reflecting. I mean, once I got this insight about 2.5 years back, I was wondering why these bunch of calculations and why did Tableau, kind of copy them and then put them. Is there any commonality? I was trying to go through this, understand. For the rest, I saw a pattern, right? So there was some position. This one, there was no button. Then I realized, so I mean, Excel had one menu, right click and show something, and then they put it in a way. Tableau also copied that and then put it here. And then percentage of total is that area that we use quite a bit. And then if you look at the forum post, a lot of these things are very difficult. I mean, if you use table calculation and slightly more complicated percentage of total, it becomes hairy, you know, really splitting the heads. So over time, a lot of these things are not just doable in Tableau. For example, if you just displaying 10 customers and you want to do a percentage of total on them, on the displayed customers, impossible to do it in Tableau. In other tools that I've used like ClickView, Power BI, it's a very easy thing to do, right? This was all before the LODs. That's why they thought through a much more comprehensive solution to this 2 levels of detail calculation, and then they put it here. So why I put it in red, it doesn't belong here. This is the odd man out. The right place for it is in LODs, really. So here is the high level concept. So let me check the time again. So I'm okay. First time I'm done on time. I actually always overrun. So this is, so I'm done 45 minutes. So let's do this. So how much time I have, Fee?
So we've got another sort of 15 minutes that's almost open there for people to ask any questions that they've got of you. Or maybe we could do a quiz for you and put you on the spot.
Yes,
First of all, I want to thank you before we get into any questions. We've got some great feedback that's coming through. I don't think that I've seen anyone explain table calculations like this before, and it's really simple and easy to break it down, and I love the use of color. But the thing that sticks out to me the most is I think that you're a natural born trainer, you know, having those quick versions in there. I know it's really difficult trying to explain these complex things to a bunch of people that can't actually talk back at you. We think it's, you know, there's so many great things that are coming through, wonderful examples and diversions. Explanation would work smoothly for most newbies. We've got good and simple examples to explain the logic, making it much more easy to understand. I love that reference to the book as well, like what got you here won't get you there. I've popped that link up in the chat for people to take a look at. I think I'm going to buy that book. It actually sounds really, really, really interesting.
Yes, excellent. Okay, so for those of you, just maybe another 1 or 2 minutes, I will do I mean, what I'm doing is, so let me show this to you. My screen is still on, right? So I have in fact started a blog series just to capture this, so that in a way, so this is what I'm kind of going to document. So you can check it out. It's tableaupro.org. And I have posted in the forum also explaining what my motivation is, what I'm trying to do, and then probably a little more detail on the story itself. I mean, in some sense, I mean, Joe Macco is not here. I mean, most of you know Joe Macco. I've had a number of sessions with Joe Macco. Joe Macco, I mean, because I work in consulting. I mean, you already know this, so you have introduced this to me. So I work on especially handling complex problems that does not use data science. I mean, this is still in the world of BI, simple BI, but these are complex problems, really, inventory problems. Sometimes, for example, IRR is an internal rate of return in the investment world. So a lot of these problems are quite complex in nature. And the moment, so I use Tableau, I get stuck. This was the case before version 9, before LODs were introduced. But afterwards, I think now, before that, I was preferring Power BI, so I any iteration that I want to do on a complex problem, I'll use Power BI. But I'm very happy to say today, I mean, if I as of now, for one of the biggest hospital chains in India, we are working on a very complex problem, finance problem. And I use Tableau to iterate. There's no visual involved. I'm working in the finance team. A lot of complex equations. We are trying to crush a process which takes so many days into a few hours. And then I use, a lot of these very quick calculations to show and help people to understand, are we talking about this or are we talking about that? So really, I mean, Tableau, the sweet spot of Tableau is quick visual, iteration, right? But with LODs, right? And hopefully once you understand table calculations better, right? So you would be able to do the same with even equations that doesn't involve visuals, right? So that way, I mean, on the market today, based on the tools that I work with, Tableau is a great choice for most of us, really, right? So another insight on LODs is LOD uses two different levels of detail. That's whenever you think of LOD, think of there is two different levels of detail. It's like one part 1, part 2 can be part 1, P1 minus P2, or P1 divided by P2, right? Or P1 is taking an aggregation of P2, but there is always two levels of detail involved, right? So exclude is about going from my child to the parent, include is about going from the parent to the child. Fixed is a little more complicated. The simplest explanation I would give to fixed is any moment you have to use blending to summarize a data set and then use that to compare. Fixed will work for you. I will explain this to you hopefully in a couple of months in my blog, right? So as I write more and more series. So fixed is my toolkit for doing ETL within Tableau, right? So I get a number of these opportunities where I have to do, for example, data set is at one level, but a lot of my calculations have to happen at a higher level. Previously, I used to use R or some other ETL tool, right, to do it outside. Now what I do is actually I use a fixed LOD to do some sort of a summarization, and then I do it inside. It's a slightly, creative use of this, which I'll explain. Even last week somebody was posting me a question from the telecom domain, and then I was able to teach them. They were coming to me with this problem. I use R to do this, but I don't want the users to do R. Is there a way to handle this in Tableau? And the solution I gave was fixed LODs. So with that, let me stop and take questions from people. So in terms of next steps, if you want to get more details, come back and follow here, give me feedback. So hopefully at least 1 or 2 posts I intend to do, hopefully as much as my schedule allows, so that this will be in the public domain. I don't have any intention of, creating a later on course that will become private. So this is knowledge that I received working with so many creative and very intelligent people, right? So that's the knowledge that I want to put out in the public domain, because Tableau is a great tool, and these kind of calculations, they are not just at the domain of Tableau. Once you understand them at this level, at an intuitive level, you can do them in any tool, really, right? They are really breakfast table calculations. So with that, I end.
That was awesome. Thank you so much. There don't seem to be any specific questions coming through at this stage, but of course you're more than welcome, everyone, to drop Siraj a note or check out his blog. I'll definitely be doing that. And if you've got any other questions, I'm sure that Siraj will be online anyway to answer them for you, so you can always direct message him.